Hello everyone, good morning. I am Rupesh H. Chaudhary of CSE AIML 5th SEM, studying my BTech in GM University, Davangere. So basically today the topic of my presentation is A-star search versus greedy best first search, pathfinding algorithm comparison. So basically today I have I have been doing this project to give a comparison between pathfinding algorithms, which are A-star search and greedy best first search. So basically, I am guided by Mrs. Shilpa RN. She is the assistant professor in AIML department and our artificial intelligence subject teacher. So team members, I'm the only member in my team. So here is my name, Rupesh Chaudhary, and my USN over here. So, introduction to pathfinding. What is pathfinding? Pathfinding is a process of finding the shortest route between 2 points. So, basically, pathfinding is nothing but finding the shortest path or shortest route between 2 points. For example, you can take A and B. So, A and B. For example, I live in Davangere and I have to find the shortest path to Bangalore. So basically, it is 260 kilometers from here if we go by road, and if we go by train, then it is just 236 or 240 kilometers. So basically, the shortest path over here is by train itself. So these are nothing but path finding, commonly used in AI, robotics, and games. So basically, these are used in AI, robotics, and many games. For example, you can take GPS also. In that Google Maps, in that it will show you the shortest path. You will have 3 to 4 paths to a same destination from a location, but you can choose from there over there. You can ask it to give you the shortest path and you can use it. Algorithms use heuristics to make decisions. Our goal is to compare A star and greedy BFS for efficiency and accuracy. So basically, we will be comparing A star and the greedy BFS path visualization algorithms to in the matter of efficiency and accuracy. So concept. So feature A star and greedy BFS. So basically the formula used is f of n equals g of n plus h of n. So basically A star uses this formula. It uses the actual cost plus heuristic. It is optimal, it is complete, but it is a bit slower, and the path quality is the best. And alongside, you can see greedy BFS, which uses the formula f of n equals h of n. It uses only heuristic. It doesn't use the actual cost. Over here, g of n is the actual cost, and h of n is the heuristic value. Over here, you can see it just uses heuristic. Not, it doesn't use the actual cost. It is not that optimal, it is not that complete, and but it is a bit faster comparatively to A star, and it is not the best. So implementation overview. Basically, I have implemented my code in Python. So the libraries that I have used is NumPy, Matplot, Lib, Heapq, and Time. So the environment, basically, I have given a 10 into 10 grid over here with random obstacles in black color that are basically the invisible or to our eye it is visible. So it is just an invisible wall to them. It can't go beyond that, and it should find a path between them itself. So the start point over here is 0 comma 0 and the goal is 9 comma 9. I have given the start and the goal part in a sense in the code part itself. Two algorithms implemented. So basically the A star and greedy BFS is also implemented over here. So what all metrics I have recorded is path length, nodes expanded, and execution time. So visualization of the path. So path visualization. A star is in the blue path. In the sense, over here, the green is the start path, which I said earlier, it is 0 comma 0. And the red part over here is the ending part or goal part. So basically over here, you can see the the blue lines. That is the A star, and the orange path is the greedy BFS. So the path of both are same. A star length is 19 and Greedy BFS, the length is 19, and the black squares, as I said earlier, are the obstacles in between that have been given. So performance comparison after running and after training the model. So over here you can see path, length, nodes expanded, and time. So this is of the greedy BFS, which is not that optimal. It is fast, but not that optimal. So I've taken only one, which is greedy BFS. So path length over here you can see, which is 19. The nodes expanded. The expanded number of nodes is 27, and the time taken is very less, which is just 0.000117 milliseconds. And the time complexity and space complexity also have been calculated over here. So conclusion. So basically over here, A star is more accurate and optimal. VDBFS is faster but less reliable. Winner is A star. So basically on the comparison of accuracy and many other things, A star is more accurate and it is very optimal and it can be used for everything over here. A star balances accuracy and efficiency. As I said earlier, A star on the basis of accuracy and efficiency, we have selected A star, and A star balances both of it. Greedy BFS is useful when speed matters more than perfection. So basically, it doesn't give us a perfect a short path, but it gives in a much more much lesser time. In pathfinding application, A star is preferred when optimality is required. So basically, when the pathfinding visualizer should be optimal, then A star search is preferred more over there. So in the next part, I'll take you to the code where I have implemented both the pathfinding algorithms. So over here, as you can see, I have said earlier that I have used Python code over here. So basically, I have entered all the values over here. So next, after running program, I run the program. It is taking a bit of time. Once again, I'll just close and open it again. So yeah, I'll show you the result at the last. First, I'll explain you the code part. So basically, over here, it has been trained properly, and you can see the results over here itself. So basically, A star uh, uh, path length equals 19, nodes expanded is 46, and the time taken is just 0.000562 milliseconds. While greedy best first search, so the path length is 19, the nodes expanded is less over here. It is not optimal that much, so only 27 nodes are being expanded. Time taken is very less comparative to the A star search, but the accuracy is very different. So you can see over here, this is the final result over here as I showed you in the PPT. So this is the green and red path, which are the start and the end, and the blue one is for A star and the orange one is for greedy BFS. So you can see the bar graph comparison also over here. So thank you. This is my presentation. I hope all of you have a good day. Thank you.